Dr. Michelle Cash, and I work at the Space Weather Prediction Center, where I am the lead of the research section. And today I'm going to tell you about the aurora. And so the aurora are the bright dancing lights that we see in the sky. You see these at higher latitudes, and the aurora actually originate at the sun. And so on the sun, we have sometimes these large solar storms. We call them coronal mass ejections. And the activity at the sun and these energetic particles will come towards Earth, and they'll interact with Earth's magnetic field. And then when these particles interact with Earth's magnetic field, some of them will come down into the atmosphere, and these energetic electrons will then excite some of the atoms and the molecules in Earth's atmosphere, and this is what creates the aurora. And so when we have these energetic electrons and they interact with oxygen ions, this is where we get the red and the green auroras that we'll see in the night sky. And then when those energetic electrons interact with nitrogen molecules, that's where we see the blues and the purple colors in the aurora. And you can also, you'll see the aurora isn't static. The aurora can move, and it can move location. It can look sometimes like it's shimmering and dancing in the sky. And the other thing you might notice when you look at the aurora is that if you see the red and green aurora, you'll see that the green color of the aurora is lower in the sky, and the red color is higher. And this has to do with, again, those energetic electrons when they're coming and interacting with the oxygen ions. When they interact with oxygen ions higher in the atmosphere, that's when you're going to get the red colors. And when they come lower, we'll get the green colors in the aurora. And so all of this starts, again, as I mentioned, it starts at the sun with solar activity at the sun, which is then driving the aurora. And so when you're wondering when you can see the aurora, it depends on how active the sun is. If it's quiet, then you're going to have to go to higher latitudes to see the aurora, so go up to Canada. However, if the sun's really active, if there's geomagnetic storms that are going on, then you'll be able to see the aurora at lower latitudes. So in the northern United States during moderate storming, and if you have a really big storm, you can sometimes see the aurora even in the southern United States or down into the Caribbean, if it's one of these really large storms that we get once in 100 years. So a lot of people wonder, when is the best time to see the aurora? If they want to go looking for the aurora, when should they go? And the best time actually is usually in the spring or in the fall. So if you go in the summer, if you're going up to high latitudes, that's not a good time because it's going to, it's not dark as much. But actually the fall and the spring are when you're gonna get to be able to see the most aurora because of the orientation of Earth's magnetic field and the way that those energetic particles, those energetic electrons, are able to have access to the Earth's atmosphere and create the aurora. So if you want to see them, go up north in March or September, and those will be the best times to see the aurora. Where did the aurora occur in the sky? So the aurora can extend from about 50 miles above the surface of the Earth to about 400 miles above the surface of the Earth. And the different colors occur at different locations. So your green aurora is going to be lower, so that occurs around 60 miles high, whereas your red aurora is going to be much higher, and that will occur around 200 miles high. So I mentioned that the charged particles are what cause the aurora, and these come from the sun. And so what are these charged particles? These charged particles are electrons and protons that come from the sun's atmosphere. So they're blown off from the sun, they come towards Earth, and then Earth, we have a magnetic field, and this magnetic field is largely protecting us from the solar wind. And so it's deflecting those charged particles, the electrons and the protons, away from Earth. However, at the poles, the magnetic field is weaker, and it's easier for those energetic particles, again, protons and electrons, to come into Earth's atmosphere. And so this is why when we want to see the aurora, We go to higher latitudes, closer to the magnetic poles, because that's where the energetic particles are able to come into the atmosphere and create the aurora, these beautiful dancing lights that we see in the night sky. So sometimes people wonder if Earth is the only planet that has aurora. And in fact, a lot of other planets in our solar system have aurora. So in order to have an aurora, you need two things. You need a magnetic field, just like Earth, and you need an atmosphere that will that you can have these energetic particles interacting with the atoms and molecules in the atmosphere. And so other planets in our solar system that have aurora include Jupiter, Saturn, Mars has a little bit of aurora, Uranus. So a lot of planets actually have aurora. And in fact, the brightest aurora in the solar system is the aurora on Jupiter. And in Jupiter, it's a hydrogen aurora, and it's in the ultraviolet.